Remember in pre-cal, the sum and difference formulas. I have them here. It's on our formula sheets. It's on reference page 2 on our formula sheets. If you scroll down, you have the addition and subtraction formulas, or in pre-cal a lot of times we call those the sum and difference formulas. Do you see the top one there, sine of x plus y equals that? Does that look familiar to you from Cal 1 or from pre-cal? A little bit? So I'm going to use that formula instead, but I'm going to have x plus h, not x plus y, right? So I'm just going to rewrite that formula with h's where the y's are. So this is going to become limit h goes to 0. Okay, this is going to become, you tell me, sine x what? Cosine h plus cosine x sine y, but we're using h, right? That's what this h is the y, so sine h, right? Y'all buy that? This right here is this according to our pre-cal formulas. What do we still have up there? Minus sine x. All of this over h. Okay? Now some really cool stuff. Well, it depends on who you ask, right? If you ask me, it's pretty cool. So what I'm going to do now is this. Because I have 1, 2, 3 terms in the numerator and 1 term in the denominator, I can split this into fractions, different fractions. And I'm going to do that. And just watch the way I do it. I'm going to do limit h goes to 0. I'm going to do sine x cosine h minus sine x all over h, and then plus cosine x sine h all over h. So all I've done here, just so you can kind of see, is I've reordered things. I put this sine x right there. That minus sine x, I put it right there instead. Move this one to the outside, and then broke it into 2 fractions. So in other words, if I ask you to put these back together, right, put them together, they have the same denominator. If I put them back together, do you agree we would be back to where we started? Everyone agree? Yes? All right. Our limit has h going to 0, right? That means this limit has no impact on x, just on h, right? Just on h. So since the limit only affects the h, what I'm going to do here is these both have a sine x in them, right? I'm going to factor out of this top a sine x. What does that leave me in here? If I pull a sine x out of this? Cosine h minus 1, right? All of this is over what? H. So I'm going to put the h under here and just, I mean, that's the same thing, right? I could put a 1 here if I want. Do y'all agree that that is this? And over here, I'm going to put the cosine x just in front of this, and I'm going to write that as sine h over h like that. Again, that's the same thing. I'm just kind of peeling the cosine out front. The only reason I did that is so you could see something in here. Hopefully you see it. We're letting h go to 0. Do you recognize this? It was one of the special limits I told you should know. We didn't use it very much, but I said we'd need it later. That goes where? 0. And this one goes to 1. That's sine junk over junk, right? And so that goes to 1. So what you have here is this sine x right here times 0, plus then you have cosine of x times 1. And so your answer is cosine of x. And that's what we said the derivative sine was, right? Yeah? So the derivative of sine of x is cosine of x. Now, what is the derivative of cosine of x? Well, we would have to do the same thing, right? But instead of using sine here, we put cosine. And then when we got to this step, this would be cosine of x plus h. And then we would use the third one there. And then we would do a similar thing, OK? I'm not going to go through it. I'm just going to tell you what the answer is. The derivative of cosine of x is negative sine of x. Not sine of x, negative sine of x. All of this these are on your formula sheets. I'm going to put them up now. So these are the rules we've gone through today. Constant rule, derivative of x, power rule, constant multiple rule, sum difference rule. We've done all those, right? Okay, then the derivative of sine of x is cosine x. Remember that, all right? The derivative of cosine of x is negative sine of x. Remember that. These are on your formula sheets, okay? These are on your formula sheets, but you need to memorize them. All right, at least sine and cosine. That should not be something where you're like, hold on, let me look it up. Okay, those should be burned in. How many more trig functions are there? There's sine, cosine, tangent, cosecant, secant, cotangent. There's 6 trig functions. And we need to know the derivatives of all of them. Now, what you need to have memorized, sine, cosine, tangent. The first 3, you need to have those memorized. All right? Those should be in here. The other 3, try and memorize them. By the time you get to Cal 2, have all 6 memorized. Okay, derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent, secant squared x. Derivative of cosecant is negative cosecant x, cotangent x. Derivative of secant x is secant x, tangent x. And derivative cotangent x is negative cosecant squared x. So those are a little, I could prove them, but I will prove tangent for you next class, not today, all right? Let me look for something here. Okay, what you're looking at right now is a Cal 2 test. Okay? And I just want you to see something on it. What's the derivative of this? So 2 is in front of the function, right? So 2 comes for the ride. What's the derivative of sine? Cosine. Okay, it's just part of a bigger problem. Let me see the next one. Okay, here. 3 tangent theta. We're using theta instead of x. What's the 3 comes down? What's the derivative of tangent? Secant squared. So on and so forth. I mean, it's all throughout this test. Well, not on this. That's just to give you an example. Like, you just, in Cal 2, you have to, when you're working the problem, you can't be sitting there going, oh, I don't remember what the derivative of tangent is. You have to know it because it's just part of a bigger thing, right? So the sooner we get these memorized, the better. How many of you need Cal 2? Quite a few of you, right? Some of you don't, so, you know, either way. All right, let me take a look at our, we still have 10 minutes, right? Make sure I've covered everything I want there. I want to look at the homework real quick. So 2.3, basic differentiation. All the way through 26, 27. Okay, yeah, that's good. If I give you a function and I tell you that the function I give you is the position of the function, what does the first derivative give you? Velocity. And what does the second derivative give you? Acceleration. Okay. There's a homework problem that deals with that, so I just want to make sure you understand that. All right, let's do this and see if you can decipher this. All right? If y equals x cubed minus 3x squared plus x minus 5, find where the tangent line or lines to this curve are parallel to y equals 4x plus 1. Now, this problem is going to seem like it's coming out of nowhere, all right? I'm going to let you write that down. While you're writing that down, I'm going to give you a picture of what I'm trying to get you to see here. So we have x cubed minus 3x squared plus x minus 5. And then I give you another line, y equals 4x plus 1. There we go. So the red curve is the graph I've given you, right? I said if I give you this curve, find where the tangent line or lines to that curve are parallel to this line. In other words, somewhere on here, right, somewhere on my curve, see the slope of this line, right? I'm trying to find where on this curve my tangent line would be parallel. Make sense? I mean, like here it's not, right? It's probably somewhere around there. And then maybe back around here as well, right? Find out where it happens. Does that seem reasonable to you? Like, does geometrically, do you understand what we're trying to do? Yes. Okay, well, what does that turn out to mean, though? Like, somehow I've got to get this. Like, we want the tangent line, right? Tangent line here to be parallel to this curve. What does that mean? Go ahead.
When we find first find the derivative.
Find the derivative, because that is the slope of the tangent line.
Set it equal.
Set it equal to what?
The slope.
The slope of the other line, right? See, this line has a slope of what? 4, right? And so what this is really asking is, where is the derivative of this, which is the slope of the tangent line, where is that equal to this slope of 4? So it's asking you to take derivative of this and set it equal to 4, right? Let's take derivative of that. What's the derivative of this? Watch the way I write this. I'm going to write y prime. The derivative of that is 3x squared minus 6x plus 1. Everyone good with that? That's just the derivative using power rule and the stuff we've done today. That's the derivative. We want that derivative to be equal to what? 4, because we want it to be parallel to this line, so therefore the slopes have to be equal. And so set that equal to 4. And what type of equation is this? College algebra. What type of equation is that? Quadratic. Do you know how to solve a quadratic equation? Yeah. I hope so. You're in this class. You've solved them at some point in your life, right? Bring everything to one side, right? Bring all terms to one side, set it equal to 0, and then try to factor. If factoring fails, you always have what? The quadratic formula, right? You've always got the quadratic formula to fall back on. So I don't see that factors. I don't think it does. Yeah, so we're going to need the quadratic formula. Does anyone have a question about why I set that equation up? Everyone understands it from the question? All right, I'm going to let you solve that yourself. This is just for fun. Quadratic formula, yes? You get two answers, right? Two solutions. Hey, didn't it look like there were two places there? The answers you get for x here, whatever x's we get, whatever we get here, would correspond to the x coordinate of the point. So, you know, whatever, let's say this one right here, looks like it's tangent about right there. Our answer will be that x coordinate. What if I change the problem and instead of said, find where the tangent lines or lines to this curve are parallel, what if I said perpendicular to that line? You would instead of doing this, 4, you would set it equal to negative 1/4 because perpendicular means that the slopes are negative reciprocals. So you would need the slope here to be not equal to 4, but to the negative reciprocal of 4, which is negative 1/4. What if I said, where is the slope of the tangent line? Find where the tangent line is horizontal. What would you do? Find where the slope is 0, right? If I said, where is it horizontal? Not parallel to this. Just find where the tangent line to this is horizontal. I'm asking you, when does the slope of the tangent line become flat, which means the slope is 0? So you'd set this equal to 0, which would still be a quadratic equation. It's just you'd get two different solutions. And on our picture, do you see that we would have two answers? Here and here, right? Those would be our two answers. Yeah? Okay, do your homework for this section. I'm looking at it. I think everything is fair game. I think some of the questions might confuse you a little bit, but do your best on them, especially when you get to like, let me see what 53 is. You know what? We can throw out 53 on the homework. For 2.3, that's this right here. Can't highlight it. I can't highlight it. Try this. So this is the homework assignment that I'm referring to here in yellow. I'm saying do all that, but don't do 53. Any questions? For 2.2, you can turn it in with the 2.3, or if you go back, you can upload it again on the other one. It'll count it late, but I'll still take it. And I'll be honest with you, on your uploaded homework, I've just been kind of giving credit grades. I always have this fear that someone's going to like submit something that says like, gotcha, I didn't turn in my homework, haha, you know, and you will get me. I'm not trying to babysit you all. You know, this is calculus, you're in college, I shouldn't have to force you to do your homework. It's something I told you I'm doing new this semester just to kind of help people, and that way I can always go back and look like, you were submitting homework, you're failing the class, but look at your homework, it's terrible, you know? So it's just to keep you honest, keep you on track. Not to say I won't look at them, I'm just saying if you see 100, it's probably, you know, and you know you only turned in half of it, it's probably because I'm just like, I'm giving a credit grade. Are we good? Have a good weekend. Do your homework. Product rule, quotient rule, chain rule next week. All right, those are the big rules. Have a great weekend. Yeah, I'm gonna turn off the camera real quick.